Hey everyone, this is Elvis from Chalk. Wanted to give a quick demo of some of the functionality that we have for data engineers. And so the first thing is that it's really easy to tell what your features are and where they come from in Chalk, and that's because all of your features are expressed declaratively. And so a good example is this normalized rating is computed by taking the rating from this review and then dividing that by the average rating across all reviews for the product connected to this review, right? And that kind of logic is really easy to express in Chalk. And so if I jump into this product feature class, I can see that we actually have this data frame of reviews, right? And once we have this data frame, we can do projections against this data frame. And so, for example, I'm going to pull out the rating column from this data frame, and then I'm going to do this mean aggregation against it, right? Or I can get the most recent rating by also pulling out the rating column and then sorting it by this other feature, right, created at, which is a timestamp. And so this makes it super easy for us to express these relationships between classes. And it's also really helpful because we can also do windowed aggregations. And so a good example here is I can take this review count over 30, 60, 90-day intervals, right? And Chalk also makes it easy to like materialize or tile this feature. And so we have this windowed config, and so I can, let's say, do a 3-day bucket duration, and then add like a cron job. That way this runs on a schedule. And so being able to like both express the features and what they mean, as well as the ETL pipelines that's creating those features, both as code and next to each other, is really helpful for giving you full visibility into both the features and how they're computed. And one of the ways that this happens is with the product ID foreign key. And so if I jump back into this review, I can see I have a product ID, and instead of this typically being like a string, we can actually point to the other feature class, and then Chalk is able to infer the relationships between these semantic models. And so this helps data engineers, data scientists express the relationships between feature classes and then have a really clean model for your data. And so the second thing I would add is that it's really easy to add new data. And so the data for that marketplace review is coming from a Postgres table. And so if I want to add a new data source, it's as easy as making a SQL file and then telling Chalk, okay, what database does this come from? What class does this data resolve? And then Chalk will go out and fetch that data at inference time and actually fetch those features and then do all of your computations. And so being able to add new data sources is as easy as like adding this SQL file. And the second thing to add here is that Chalk also has a lot of primitives for doing things like incremental ingestion. And so I can also say like we want to incrementally, let's say, run a feature pipeline that only looks at the new values from the last time I ran that feature pipeline, right? And so we can do this with what's called a scheduled query. And that scheduled query will essentially take this like column created at, and then it can use this column as a high watermark and then only ingest new values since then. The second thing I wanted to show you is validation. So you can actually do feature validation at the feature level. And so I can say we expect this rating to be at most 5 and at minimum 1. And I can actually have Chalk validate these feature values. And I can also do this for larger queries. And so I have this test marketplace file. And so I can set up this like test fixture. I can pass in this like Chalk client, and passing in local is true will essentially have Chalk deploy the local Git branch. And so if you like make changes to your features for testing and they're not essentially pushed up to production, you can have Chalk deploy that to a branch, and then you can like run like historical production traffic through that branch, and local makes it easy for you to do that. And so a good example here is like I can essentially say, suppose we have this imaginary user with ID 1, and I can actually create a data frame of reviews for that user, and then I can have the Chalk client check these feature values with expected output, right? So if I go down to my assertions, I can see like we expect the review count over the past 3 days for this data frame to be 3, we expect it to be 7 for 7 days, and we expect this average rating. And so this is a really nice way for like testing your features and testing your feature logic. And one other thing I wanted to show you is that we also have a ton of charts and metrics against either features or sets of features. And so if I go to my Chalk dashboard, I can go into this marketplace review, which is my feature class, and I can look at the star rating, and then I can get a chart for, let's say, how many times this feature was requested within some time interval. I can also look at whether or not another resolver or another feature depends on this feature, right? So we have this get normalized rating function, right? I can actually jump into this function. I can also see it in the code. So if I jump into the code here and I scroll down, I can see get normalized rating actually depends on star rating, right? And so this helps data engineers find, like, okay, what depends on this feature? How can I have data lineage across a bunch of features and then know that I'm not breaking some downstream pipeline? Yeah, so those are some of the things that are in Chalk that help data engineers.